Hello, ladies and gentlemen. Welcome to our next webinar session dedicated to AI machine learning solutions for soil organic carbon sequestration. My name is Sergey Litvinov, and I'm Senior Account Executive at EOSDA Analytics, and I will be very happy to tell you more about our solutions. And please also meet our colleagues who will be co-hosting the event with me, our Product Manager, Regina Urazmanova, and our Business Analyst, Alexei Neskrovny. So, before we start, let me quickly share our webinar agenda with you. And today we're going to be speaking about the history of EOSDA. So for those who already know about our company, we're very thankful that you joined the webinar. But for those who are here for the first time, bear with us, and we will be there with to tell you more about soil organic carbon sequestration modeling. So we're going to be speaking about product portfolio for agriculture and soil organic carbon modeling, and of course, solutions required for sustaining soil organic carbon projects, such as soil organic carbon assessment, analysis, methodology, and description. So data required for soil organic carbon projects, cover crop, crop rotation, tillage detection, field boundaries detection, and crop classification. And of course, there will be some real-world use cases. And at the end of the webinar, we are going to be speaking about, we would be very happy to answer any questions you may have. So let's move on. So the company, EOSDA Analytics, is a privately held company which owns 3 out-of-the-box solutions. The company is headquartered in Mountain View, California, and we have 250 people led by 5 professors and 15 PhD scientists. So we partner with governmental, commercial, and scientific organizations and provide diverse solutions. So the company was founded in 2014 by Dr. Max Polyakov, and it evolved into an organization that provides a lot of services such as land viewer, crop monitoring, forest monitoring, and of course, some custom solutions such as crop classification, field boundaries detection, soil moisture, yield prediction, and of course, soil organic carbon modeling. And also in January 2023, we launched satellite EOSat-1, which is completely dedicated to agri-related purposes and is already available for commercial usage. And before I'd like to dive into some additional projects, such as crop monitoring platform and API. So crop monitoring platform is the platform that allows you to monitor crop health, weather risk management, and it also provides some scouting and task management, farm organizer, and planner. So the data is also available through the API, which means if you're using any software that requires additional data enrichment, you can easily use our API to build something from scratch, or additionally input additional data sets from our API. Also, the crop monitoring platform can be white labeled, meaning that you can add additional value revenue stream to your organization. And if you're just looking for the out-of-the-box solution, feel free to reach out to our sales team, and we will be very happy to discuss with you our partnership program. And of course, a part of the crop monitoring platform, we provide some custom solutions such as crop classification, harvest monitoring, identification of field boundaries, yield forecast, soil moisture analytics, and of course, the gem of our today's webinar is soil organic carbon modeling. So, and also our clients include, we work with hundreds of customers all around the world, and some of them is the Morningstar, the biggest tomato producer. You can read the use case on our website, the World Bank, Bayer, Syngenta, and many other companies. So I'd like to pass the word to my colleague Regina, who will tell you more about soil organic carbon assessment. Regina, the floor is yours.
Yeah, thank you for yielding the floor to me, Sergey. I'm Regina Urazmanova, the Product Manager of Carbon Solutions at EOSDA. Now I will delve further into the topic of soil organic carbon sequestration, and I will tell more about our EOSDA solution. But first and foremost, allow me to provide a brief introduction. Soil organic carbon sequestration is a process of storing carbon from the atmosphere in soil through the decomposition of organic materials. This process plays a crucial role in mitigating climate change by demonstrating the amount of carbon dioxide present in a year. So let's start with our solutions. So organic carbon assessment, it involves calculating the current spatial distribution of SOC, serving as a foundation for modeling its potential accumulation or loss in the future. At EOSDA, we developed two key models. The first model, this extrapolates spatial distribution based on physical soil samples. This solution improves decision-making regarding the allocation of resources, for example, implementing variable rate application. Also, it serves as a baseline for carbon credit generation, thus creating more positive environmental footprint with higher profits. Also, it establishes a starting point for creating a report for claiming carbon credits. Because for reporting, we must understand the initial carbon levels present before any activities. Also, this model facilitates the creation of accurate soil maps. It's important to note that the resulting accuracy of the model surpasses that of interpolation laboratory soil samples analysis because it incorporates various parameters such as climate, weather, and other, resulting in a more precise distribution of carbon on the map. Let's talk about second model. When it is designed to predict changes in soil organic carbon content over time. To achieve this, we utilize the adapted and enhanced ROSC model. Furthermore, we incorporate the baseline established by the previous model I mentioned. We gather a substantial amount of predictors, up to 130, to identify the most suitable ones, considering factors such as climate, location, and other parameters. While some data is required from your side as a customer, we also can provide certain data from our side, such as vegetation indices derived from satellite images or weather data. Additionally, EOSDA offers solutions like boundary detection, streamline project scope. My colleague Alex will tell us more about this aspect later. The main benefits of this model with RODC, it's saving project budget on soil sampling during follow-up activities with potential reduction of up to 90% in the number of soil sampling required, estimating profits from carbon credit generation, monitoring the sequestration of soil organic carbon throughout the entire project duration. Now let's discuss the USDA SOC analysis methodology description. So the ROSC model I mentioned earlier is utilized by the Food and Agriculture Organization by the United Nations. Additionally, this model is recognized by government entities such as the National Greenhouse Gas Inventory of Japan and also Australian government. Ahead of the questions, I would like to say that for the forecast, we indeed utilize the ROSC model as our foundation, but we have made significant improvements to it. For example, implementation of higher spatial resolution data up to 10 meters resolution compared to the 1000 resolution available in the basic version of ROSC model used by FAO. Also reduction of carbon levels for any 20-year period, unlike RODC, which is limited to 20 years and lacks flexibility in selecting different time frames. Our calculations are compliant and adjustable for the following standards: Clean Energy Regulator, VERA, Gold Standard, Climate Action Reserve, and others. I previously mentioned the data required for soil organic carbon project. Now let's briefly delve into the main types of data needed. For our model, we require weather data, average monthly temperature, precipitation amount, evapotranspiration. Also, of course, the main data is soil analysis. So for soil data, we need organic carbon content and clay content, the main one. Also important, relief data, digital elevation maps, such as the shuttle radar topography mission with 30-meter resolution or light detection of ranging with 5-meter resolution. Of course, vegetation indices, for example, normalized difference vegetation index, also known as NDVI. or normalized difference red edge indexes, and also known as NDRM, or some other satellite data, for example, like dry matter productivity. We need for modeling land cover data. And just quick reminder, we can utilize up to 140 predictors and pick up the best ones for your project. It depends on the territory and location. Carbon projects typically span several years, sometimes even decades, to complete. While carbon models play a crucial role, achieving optimal results necessitates the integration of various other solutions. With carbon models, we establish the baseline and generate forecast, enabling cost saving on soil sampling. However, throughout this process, it's imperative to monitor the field activities required for soil organic carbon sequestration. And here I would like to tell more about it. So the first solution, let's begin with cover crop identification. A common practice for sequestrating more soil organic carbon on farms is to seed cover crops. This practice enhances soil organic carbon sequestration by boosting biomass production, facilitating nutrition release from roots, enriching soil fertility and structure, and reducing atmospheric carbon dioxide levels. We employ geospatial technologies, leveraging vegetation indices such as NDVI to remotely identify cover crops across multiple of fields simultaneously. With this data, you can readily assess the farm's compliance with objects of the carbon credits project. Second solution I would like to tell more, it's crop rotation. Because the practice of crop rotation enhances soil health by forecast diverse organic matter and microbial activity, thereby improving soil structure and promoting carbon sequestration. Presently in EOSDA crop monitoring, our solution that my colleague Sergey told before, in crop monitoring enables manual tracking of crop rotation. However, we actively developing a modeling solution to streamline this process and save customer valuable time. And the final solution I would like to cover today is tillage detection. Monitoring tillage activities in the fields is a crucial component of carbon projects. For instance, carbon project developers can save time and effort by leveraging remote sensing technologies instead of conducting physical inspection of farms and assess tillage production. Our current developments use Sentinel-1 data, and the model resolution is about 20 meters. So that's all from my side. And now I would like to yield the floor to Alex to provide further insights in the custom EOSDA solution that will enhance the carbon projects.
Yeah, thank you, Regina. Hello, everyone. I hope you hear me well. My name is Alexei, and I'm a business analyst in EOSDA. And my main task here is to understand the customer requirements and ensure the clarity of these requirements to our science and technical team when we implement different custom projects, including projects that relate to soil organic carbon. And as Regina previously mentioned, the carbon projects are comprehensive solutions that may include not only the soil organic carbon content calculation or modeling itself, but also many other additional steps and preparatory operations. For example, to start modeling spatial distribution or forecasting of soil organic carbon content, in some area of interest, we usually first need to prepare a set of minimum required model predictors and other supporting data. Such data, among the main things like soil lab analysis results, soil types, terrain data, weather data, can also include the field boundaries, detection of the target fields for which the modeling is necessary, or, for example, crop calendar and information on which crops are being grown in the current and the previous seasons for these target fields. And some of this information we can obtain from our clients, especially in cases where the company maintains a high level of field management culture and extensive digitalization. But in cases where the client does not have such data, or such information is not complete or reliable enough, we try to help our clients to obtain predictors based our in-house solutions. For example, I would like to dwell in more details on two technologies, namely the field boundaries detection and crop classification. And yeah, let's start with field boundaries detection and its value in carbon-related projects. Often, soil organic carbon content modeling is required at the level of specific fields. For example, when we want to understand the amount of soil organic carbon in tons or kilograms in a certain field. Or, for example, when we want to compare several fields based on soil organic carbon content as a criterion. In such cases, in order to calculate the total soil organic carbon on a field, we must know its exact area, and accordingly, we need to clearly define the boundaries of the field. Again, sometimes clients do not have this information in electronic format, or such information is not available for all client fields, or it is not sufficiently reliable. In such cases, we can apply our field boundaries detection technology to the client's target areas of interest and use the detection results in the carbon project as an input. To detect field boundaries, we use technology developed by EOSDA. The technology is based on a semantic segmentation convolutional neural network model. And the model was trained based on data sets from more than 10 countries in different parts of the world. This technology relies on cloud-free and contrast satellite imagery from Sentinel-2 optical sensor. And images are typically selected in middle of the growing seasons when the fields are best identified as a separate objects to ensure the maximum chances of accurately detecting the field boundaries. And the results of model validation that we performed with our team in different regions of the world show the accuracy up to 90%. And validation was performed based on the so-called intersection over union metric, which in real life means that we compare the field contours obtained after the modeling with the ground truthing data, namely the field contours collected directly from the fields by scouts or by our partners in other countries where we are not present. And there are some factors that can negatively affect the accuracy of the model. And mainly, this is the cloudy images, cloudy areas, small fields, and some specific terrain features like very mountainous terrain. But we try to neutralize these factors. For example, to solve the problem with clouds, we can use several images which are partially covered with the clouds to combine them and ensure one combined cloud-free coverage for the area of interest to ensure the boundaries detection for entire area of interest of our clients. And if we are talking about the issue of the small fields, the model can be adapted to high resolution images if this is necessary. A couple of words regarding the projects and the data that we need to implement these projects. And to be honest, to detect field boundaries, we do not need almost anything from the clients. Basically, we use only the area of interest in a KML or shape file format as a main input, since the model is already trained in different regions. But we can ask our clients for some additional useful data that may include crop calendar to choose the best period to detect the boundaries, to choose the high vegetation season. and high vegetation period, I would say, and some ground truthing data if it is available from the client to do some additional validation in specific regions. Regarding the format of the results that the model produces, it is usually a vector layer with the field boundaries in KML, shapefile, or GeoJSON. And this format allows you to use the results in any GIS tool or even visualize them if necessary in any web platform that you own. And such layers can be used, as I previously mentioned, as data input for soil organic carbon modeling, or even a separate products for other clients' purposes, such as digitalization and inventory of fields, assessment of acreage, and tracking the acreage changes in dynamics. Also, these data can be used for a wide spectrum of agricultural operations by loading these layers to combines, tractors, or other machinery. And another thing regarding the output format, if necessary, we can provide some extended reports with more tables, spreadsheets, infographics, and other analytics. Again, if this is required from our clients. And a couple of words regarding the crop classification. This technology allows us to determine which crops are grown in target areas in the current season, and most importantly, in the previous seasons. This means that using crop classification technology, we can determine crop rotation patterns on a specific fields over a certain period of time, even if the client doesn't have this information for previous seasons. And as we already discussed, crops rotation is a significant factor. Then when we're determining the current value or even predicting soil organic carbon content, this is due to the fact that different crops have different effects on carbon sequestration into the soil, as Regina already mentioned. And in addition, scientific paper shows that the crop rotation itself enhances soil organic carbon content by more than 5% relative to continuous crop monoculture. So because different crops have different root structures and growth patterns, which can influence soil carbon sequestration. A couple of words regarding the model and the technology. We use the model based on convolutional LSTM, where LSTM means long short-term memory networks. To explain this in a simple way, the main advantage of such model is that it can be trained based on the time series of images, not based on one or two images. This means that the model can take into account the spectral characteristics of different target crops in different stages of growth during the vegetation season, which increases the chances of accurate detection. This model also uses a time series of cloud-free Sorry, can you hear me, guys? Yeah, sorry for that. I will start maybe regarding the model one more time to be sure that you didn't miss something. So we use, as I mentioned, a convolutional LSTM model, and its advantage is that the model can be trained on the time series of the images during the vegetation season that can ensure the better accuracy of the crop classification. And this model also uses a time series of cloud-free images from Sentinel-2 optical satellite, in particular RGB channels, near infrared and shortwave infrared spectral bands. And a few words about the factors that influence the accuracy. The model can reach again up to 90% depending on the region, crop, and especially available ground truthing data. There are also some limitations as well here, like cloudy regions, the size of the fields again. If you're talking about the fields like less than 3 hectares, the things may be more complex here. And as well as specific crops or similar crops in spectral characteristic, for example, like wheat and barley. But there are also some ways to neutralize the influence of these factors. And we can, if we have a goal to detect, for example, some specific crop non-typical for like non-typical agro crop, then having the sufficient amount of reliable ground truthing data, we can perform additional training in this region and retrain the model and significantly increase the chances of successful crop detection, even it is a very specific crop. And regarding our requirements to perform these projects, we usually ask clients to provide the area of interest, again in electronic format, the list of typical crops for the region, as well as ground truthing data, at least a small amount to train the model. When I say ground truthing data, I primarily mean the examples of target crops in the area of interest with precise georeferencing. For example, it can be some geopoints or polygons with metadata where we can understand that in this particular field, for example, wheat or corn was grown on some specific season. And again, if there is no ground truthing data from the client side, we can train the model based on available open source data, but it is always better to have some reliable data from the specific region and the specific season to better train the model and to get better results accordingly. As for the results and outputs of such projects, it can be a raster per pixel data or a vector layer that contains geolocated data about detected crops for area of interest. And again, this data can be used as an important predictor for soil organic carbon, as we mentioned a couple times here on our event, and as well as a separate data set. We can use it as a data set for other purposes, for example, logistics and warehousing, planning, some internal analytics, and etc. So I believe this is basically it about the crop classification and boundaries detection. This is almost all information that I wanted to share with you. And now I want to pass my word to Sergey. I believe we will go to more active phase of our webinar. Thank you.
Thank you so much, Alexei. Thank you very much, ladies and gentlemen, who are staying with us. And we are very happy to receive a lot of questions from you, which we're going to be covering very soon. But before we continue our webinar, we prepared a very interesting quiz for you. So please answer the questions you see on your screen. And so there will be 4 questions so far. And I will start with the first question. So we'd like to understand what you know about soil organic carbon sequestration, and that would really help us. So the first question is, are you engaged in fieldwork practices for soil organic carbon sequestration? So there are 4 options to answer. Absolutely, it's essential for progress. Yes, it offers significant benefits, sometimes depending on circumstances. And no, exploring other options is preferable. So I will wait while you answer the first question, and we will move on to the second one. Yeah, I see some very interesting answers. So thank you so much. Thank you very much for being so active today. And let's move on to the second question. So, have you ever registered in a carbon credit generation program? Yes, all my projects fields are registered. Yes, I've just begun doing so. No, but I'm considering it. No, I don't see the sense of it. Please take your time. Okay, so thank you so much. Thank you very much for your activity today. And let's move on to the third question. Do you support using remote sensing to monitor field activities? Absolutely, it's crucial. Yes, it's beneficial. Maybe, has potential. No, prefer alternatives. Thank you. Thank you so much for your activity today. I see so many votes, and like that is really impressive. So thank you so much for being so active. And let's move on to the last question. So do you believe that soil organic carbon detection could be achieved through remote sensing? Absolutely, it could be. Yes, but maybe in the future, maybe with more testing. No, it's impossible. So thank you so much. Thank you so much for your activity. And let me quickly share with you the results. So for on the first question, we see that 14% of people are engaged in the fieldwork practices for solar organic carbon sequestration. 15% of people answered absolutely. 12 answered yes, it offers significant benefits. 18% sometimes, depending on circumstances, and 18% no, exploring other options is preferable. So, the second question is, have you ever registered in a carbon credit generation program? So only 2% of people answered yes. 5% of people answered yes, I've just begun doing so. 36% of people no, but I'm considering it. And 5% no, I don't see the sense of it. The third question is, do you support using remote sensing to monitor field activities? 28% said absolutely it's crucial. 15% of people said it's beneficial. 8% said maybe, it has potential, and and people answered no, prefer alternatives. And the last question, do you believe that soil organic carbon detection could be achieved through remote sensing? So we've got 27% who answered absolutely it could be, 6 yes, but maybe in the future, and 19% maybe with more testing, and 0 people answered no, it's impossible. So I thank you so much for being so active today. So, and thank you very much for taking your time to answer our quiz questions. So we can end our voting. Thank you very much. So let's move on to our next part of the webinar, in where I'd like to cover some real world use cases with you. So one of the use cases was field boundaries detection, and we accomplished the project for the very large Canadian bank. Unfortunately, we cannot reveal the name here, but we can tell you that the area of interest was 10,000 square kilometer, and we used Sentinel-2, a satellite, to detect the field boundaries. So the output format that we provided to the client was in vector mask with field boundaries, in shapefile, and GeoJSON format with recorded field IDs, coordinates, and area. So that was like the zoom out version of it. If we zoom in a bit, we will see such a picture. So as you can see, we managed to detect all those field boundaries within this area. provided by the client. And we use machine learning technology to automatically filter out or unnecessary areas. Also, in our software, Aspectum, we managed to visualize the data. So, and also made it more interactive. So basically you can click on any field and it will give you a field ID, an area, the total area of the field. And this is how we also deliver the data. We can also provide data in spreadsheet format or in any other output format based on your preferences. So let's move on to another use case, crop classification. So that was done for the agricultural cooperative in Greece, and the project goal actually was to detect to verify the credibility of the local farmers receiving subsidies from the local government, and that's why the client of ours, they requested this data from us and help them to identify some target crops based on their requirements. So the output format was the vector mask with field boundaries and classes in shapefile format with unique field IDs, area, and crop types recorded in metadata. So this is another visualization of how we managed to do this. And usually we visualize all the data sets in our software called Aspectum. But of course, we provide additional data sets to our clients in spreadsheet, vector masks, and layers, and raster formats. So this is just the visualization of the data, and just look at how beautiful it is. So the fields were pretty tiny, like some of them were 1 hectare, some of them even was less than 1 hectare, but we still managed to detect field boundaries, and we used Sentinel-2 data for this. Even though the satellite provides 10 by 10 meter resolution, we managed to detect pretty tiny fields. And you can see there were some target crops for the client. So it was corn, canola, sunflower, tomato, wheat, and cotton. Each color represents each crop. For example, red means tomato, yellow means corn, or orange means cotton. And if we zoom in a bit, we can see there is a kind of interactive map available. So we can click on any field and we can interact with it. So we can see the crop class, which is wheat, and the total area of the field. And the last but not least, it's soil organic carbon modeling. So the use case was done for Australian leading soil organic project developer called AgriProof. So it's a 2-year project funded by the Australian government with a $9.2 million grant. And what we did exactly, so the technology under the development will definitely harness various indices from both optical and SAR images, and along with a comprehensive set of predictors that we're using, including digital elevation maps, model, and their derivatives. So we also are using bioclimatic indicators and soil data. So these data sets analyzed using advanced machine learning models can be used for direct soil organic content modeling or integrated into the Roth-C predictive carbon cycle model. And of course, as the project goal of it is to establish a farmer-led commercial model of soil organic farming, regenerating agriculture and sequestering carbon at a scale. So Carbon Project enables farmers to generate income from carbon abatement activities and secure sustainable returns in the Australian market. So to put it simply, we help farmers to save budget up to 90% on soil samples. And we can easily do this with you if you have soil samples data, and we will be very happy to help you to build this soil organic carbon modeling. And if you have any project like this, feel free to reach out to us. We will be very happy to work with you and give advisory on how to proceed in such a case. So thank you so much for your time today, and we're moving to our Q&A session. We received a lot of questions from you today, and let me quickly read the first question, and we will start from there. So the first question is, near real time, what does it mean? Which satellite is used? I can answer this question. So normally we are using Sentinel-2 and the satellite EOSat that we launched in January 2023. So basically, these are two satellites that we're using for soil organic carbon modeling. But of course, we may use any additional satellite available. It depends on the kind of the preferences of the client, but normally we're using these two satellites for soil organic carbon modeling. When it comes to other projects such as crop classification or field boundaries detection, we definitely can use like both satellites, but additionally we can use any other satellites available depending on the preferences of the client. So for example, if the client needs high resolution imagery to be used, we can easily do this. So another question, for a graduate student, what research area can be done using AI and machine learning? So if you have any project right now, please reach out to us at sales@eosda.com, and we will be very happy to help you there. So we don't know like the exact specific of the project, but please reach out to us and we will see if we can help you here. And the fourth question is this model described by Regina for soil organic carbon assessment and modeling for farmlands also applicable to forest lands? So, Regina, please, the floor is yours. Over to you. I see you can answer the question.
Yeah, I'm back. Blin, could you repeat the question, please? Oh, Sergey, you can.
Yeah, sure, Regina, not a problem. So the question was, is the model described by you for soil organic assessment and modeling for farmlands also applicable to forest lands?
Okay, thank you. Yeah, because I'm reading the comments and it's a lot of questions. Really, thank you for these questions. It's really interesting discussion about forest lands. So if we talk about forest lands, we also can use our modeling because the basement of our model is soil sampling. If we can take soil samples, we can do our models. If we're talking about carbon forest models, we can't use our model soil organic carbon. We need other models. The difference is ground truth data, because for soil modeling we need our ground truth data is soil samples, and for forest we need for modeling we need such data are trees coverage, trees type, and others. Yeah, so if we talk about forest lands, yes, we can use our models. And if we talk about forest carbon, no, we need other models. We also have it. It in EOSDA. Yeah, but we didn't mention about them today. Thank you.
Thank you so much, Regina. So let's move on to another question. To what soil depth is modeling accurate, and what soil organic carbon percentage is the model limited, please? Regina, I think you can answer this question as well.
Yeah, I also can answer this question. Average for average for modeling, we need 30 centimeters depth. Yeah, for other question, we don't have here scientists, unfortunately, but I think we don't have any other limits.
Okay, thank you so much. And let's move on to another question. So what information does the field boundary tell you if you're already providing areas of interest? Alexei, please, the floor is yours.
Sure, just a second. Sergey, can you please find what information does the field boundary detection tell you if you already provided area of interest? Yes, sorry to asking this again. This question we're discussing. Yeah, when I said that we need the area of interest, I meant, for example, if we need to do some modeling of soil organic carbon in some province, for example, in France, then we need the area, let's say the extent area of interest from the client, for example, some province in electronic format or some regional, some settlement inside this province. And if the client doesn't have the exact contours of each field, and the client want to model the soil organic carbon in a field level, in these cases we can apply our boundaries detection model. But yeah, if the client can provide all the field outlines in this, let's say, settlement, of course we will not apply the boundaries detection. This is needed for cases when, again, as I mentioned, when the crop management culture is not very high, and here we can step in and suggest our solutions like field boundaries detection, that we can as a result, we can detect these fields boundaries and calculate soil organic carbon content or model it for future per field on a field level. Thank you for the question.
Thank you so much, Alexei. So let me quickly jump to another question. So what is the accuracy of the boundary data and orthophoto combined? So normally I can answer this question. So normally the accuracy is up to 90%, but of course it depends on the area of the land and the average size of the field. So if we're using super small fields, like less than 1 hectare, we would definitely need to use high resolution imagery. It could be sub-meter resolution imagery. But if we're speaking about fields of more than 1 hectare, we are normally using Sentinel-2 data with a 10 by 10 meter per pixel resolution. And of course, the accuracy is up to 90%. So the next question is, are you able to identify cover crops? So I think, Regina, if you could answer this question, that would be great.
Yes, I can. So if we need to identify, do we have cover crop on the field or not, we can just use NDVI index or other index that you would like to use. We don't need ground truth data, so it's really easy, scalable, and we in EOSDA, we have really strong expertise on it. But also we can identify which crop exactly is seeded right now. We also have model on it. My colleague Alexei mentioned about this today. It's more complex model because we need more ground truth data. Yeah, but you can understand which crop exactly in the field. Yeah, I think that's all. Thank you, Sergey.
Yeah, thank you so much, Regina. So let's jump to another question. Do we need to send you the soil samples for the baseline? So Regina, I think you can also answer this question.
Yeah. Yeah, for baseline model, we need soil samples because it's basic. Unfortunately, for now, we can't detect soil organic carbon without any soil sampling. Yeah. Our scientists also research this question. We would like to. We will be developing some technologies on this field, but for now, it's really impossible. Yeah. Sergey.
Thank you so much, Regina. Yeah, and let's move on to another question. So while soil organic carbon can be variable for a field 160 acres, are you able to identify major 3, 5, 7 zones within the field? Alexei, I think you can answer this question.
Yeah, I will try if I understand the question correctly. So the question is, if this is a big field, will we provide just one number, one value of soil organic carbon per field, or can we do this more precisely? And the answer, we can identify several zones for sure. because our models can reach the spatial accuracy up to at least 30 meters. So this means that in these 160 acres, we will have at least a few pixels. In each pixel will have the value of soil organic carbon, because we use not only the soil samples, but other data such as relief data, some satellite data, and we can find this variability on the different parts of the fields with a resolution up to 30 meters. So I believe this answered this question, hopefully.
Thank you so much, Alexei. So we've got another question is why clay content is important for soil organic carbon models. What it is about clay that matters so much? Okay, I think I understand the question. I will try to answer it. So first of all, clay has a high surface area, and it negatively changed, so allowing it to attract and hold water and nutrients. So this is just one of the properties of it, and this is why it helps to this property influences soil moisture levels and helps, basically it's just very important for this. And also clay plays a role in protecting organic matter from decomposition through processes such as a physical protection and chemical stabilization. So I think I hope I managed to answer this question, but there is a kind of study about soil organic, why clay is important for this. And if you would like to dive into this, and if this is important for you, please send us an email at sales@eosda.com, and we will be very happy to assist you with your project. So let's move on to another question. Okay, so the question is, soil sampling is a must, but can we get the tests done from the local lab, or we have to send the samples to EOSDA? Regina, I think you can answer this question.
Yeah. So in EOSDA, we are software. We don't have any labs to do analysis. That's why for modeling, we need, in the best scenario, we need a table with soil analysis where provided the main information about soil. Of course, it's organic carbon content, clay content, and it's really important geolocation, because sometimes we get tables without soil samples without geolocation. It's really hard for us to understand what's going on in the field. Yeah, and I believe that local lab is can do the best for soil analysis, because local knows the territory is the best. Yeah, thank you.
Thank you so much, Regina. So let's move on to another question. Okay, do you have accuracies for different parts of the world, such as US, Canada, Brazil, etc.? I can answer this question. So first of all, I think the accuracy depends on. So first of all, we just need to understand what you mean by accuracy. Which projects do you mean? Is it like soil organic carbon modeling, or is it crop classification or field boundaries? But overall, the accuracy highly depend on the input data. If we're speaking about the soil organic carbon modeling, and if we're speaking about crop classification or field boundaries detection, normally the accuracy depends on which satellite images we're going to be using for the project. So I hope I managed to answer this question. So let's move on to another question.
Sergey, can I comment a little bit on this question more? Oh, yeah. I believe I can add something. Yeah, if we are talking about, let's cover all of these projects that we mentioned. If we are talking about the crop classification, as I mentioned, the cloudy regions like Indonesia, for example, Philippines. There, it's more complex projects there because we have the smaller amount of cloud-free images, and these can affect the accuracy. Another thing is the small fields, for example, and the US and, for example, Canada. In some European countries, the accuracy may reach 90%, 80%. But in some countries, like in Africa or Middle East, where the fields are small, the accuracy will highly depend on the second important part is ground truthing data. So if we have enough ground truthing data, then accuracy can be higher. So we can't answer directly. We need to discuss each case, I believe, separately. And if we are talking about the field boundaries detection, here the things are easier. The let's say the less cloudy region and the bigger fields, the better accuracy. And regarding the soil organic carbon project, I will try also to comment on special accuracy, meaning the special resolution, at least in the different parts of the world. For example, it very depends on the terrain data that we have in different regions. I mean, for the special resolution of the model. For example, if we have the global coverage with some open available terrain data set, which is 30 meters in resolution. So this is the one level of the accuracy of the special accuracy. And for example, in Australia, they have 5 meters terrain data from LiDAR. And as you can understand, the accuracy, the special accuracy will be much higher here. And yeah, and it also can depend on other different input data that clients can provide to us. So yeah, if you have some maybe specific projects, you can specify the country, the area of interest. We can assess this more accurately. Thank you.
Thank you very much, Alexei. And let's move on to another question. So we have so many questions today, but let me just quickly read another one. Would it be possible to train this model based on multiple sensors data? Alexei, I think you can answer this question.
Yes, yes, I will try to answer these questions as well. So the short answer is yes, but again, here we can understand this question different ways. For example, we can use different special resolution of sensors. For example, we can use, for example, Landsat optical imagery, or with 30 meters resolution, or Sentinel-2 satellite with a 10 meters resolution, or we can use, for example, EOSDA with 3 meters resolution. So here is the one option. And yes, it's possible. And in different, let's say in different regions, in different parts of the world, these predictors can show the different, let's say, efficiency. In some region, it can have the high influence on the result, in different less influence. And the second part is the type of sensor. For example, in Australia, we are experimenting now with radar data, with SAR data, and there we use some Sentinel.
So I think Alexei lost connection. Probably, yeah, I think he will be back very soon with us. So let's wait a couple of seconds if he will rejoin. And if not, I'll think we'll let him finish answering the question when he established the connection back. So really appreciate your understanding. Oh, Alexei, you're here. So
I don't know, to be honest, I don't know where you stop hearing me, but I will try to briefly explain this again. So yes, the answer is yes, we can use different sensors, and we can use different spatial resolution of sensors, and we can use different types of sensors like SAR data and optical data, and as well we can use different spatial resolution of SAR data. For example, in Australia, we experimenting with Sentinel-1 and some more high-resolution commercial data. And again, for different regions, different spatial resolutions and sensors work differently. Thank you.
Alexei, thank you so much for answering the question. So let's move on to the second question. I'm sorry, to the question 17. So, does your crop identification tool have the capacity to develop crop-specific yield monitoring and or forecasting outputs? So I'll try to cover this question if I got it right. So we can definitely do this. So after the crop classification, we can predict yield on a field level, state level, or a county level, or a region level, depending on where we are just focusing on. So we just need to know some, we're going to be building this yield prediction either on a biophysical model or a statistical model. By biophysical model, I mean that we will be modeling the yield. But with a statistical model, if you can share with us any input data, such as yield for the previous season or calendar crop or anything that would help us to feed the data to the our model, and it will be trained on this data, and we will, as an output, we will be able to provide this data in terms of yield prediction. So yield prediction modeling, normally we guarantee accuracy for biophysical modeling. It's between 80 to 85%. And when it comes to statistical modeling, it's between 85 to 95%. I hope I managed to answer this question. And let's move on to another question. Are you able to identify changes to soil organic carbon over the years with your predictions, or are your soil organic carbon predictions for the last 3 or
I hope you can hear me well. I lost connection with Sergey. But yeah, the question is, are we able to identify changes of organic carbon over the years with our predictions? So if I understand the question right, we can forecast the amount of soil organic carbon in any period, the time you would like to have. I mean, our suggestion is at least 1 year, because soil organic carbon sequestrates, I would say, low if you compare with other the soil content. But yeah, if a customer needs understand the forecast of soil organic carbon in 3 years or 5 or 20, we can do this. So the basement of we using is ROSI model, and we can, thanks to this model, we can do this. Yeah, thank you, Sergey.
Thank you very much, Regina. So let's move on to another question. Okay, what temporal resolution is your crop classification? Alexei, I think you can answer this question.
Yes, as I mentioned, we use Sentinel-2 optical data for crop classification, so the spatial resolution of the result is also 10 meters pixels. Yeah, this is it. So we potentially can consider some different options, like more high resolution imagery, but in this case, the cost efficiency of the projects can be lower. So that's why the current option is 10 meters spatial resolution.
Thank you very much, Alexei. So we have another question. Are your satellites able to help with large farms in Africa? Yeah, sure. So we work worldwide, so meaning that we also work with the African countries and we have clients in Africa. So please reach out to us if you need any help at sales@eosda.com, and we will be very happy to help you with your request. Is the data sets freely available online? Not sure if I understand the question correctly. So, but what data sets you mean? So please clarify your question, or please send us an email at sales@eosda.com, and we will help you with this question after the webinar. So we still have a lot of questions, and
Sergey,
yep.
I'm sorry for interrupting you, but I mentioned that the question was basically what temporal resolution is your crop classification, and I commented on spatial resolution. Sorry for that. And yeah, I will briefly comment on temporal resolution. Resolution as well. So the temporal resolution is depends usually on the crop maturity. I mean, basically we try to do the crop classification one time per season, or we can do early and a later classification, but we need to do the classification and at stage where the crop growth stage is mature enough, when this crop have some specific spectral characteristics that our model can capture. Yeah, thank you. Sorry that I didn't understand the question correctly.
Thank you so much, Alexei. So there is a question, what other customers you're working globally for carbon sequestration? So far we can only reveal the name, like publicly available case study that we published with AgriProof. But of course, there are many other customers we are working with. Unfortunately, we cannot reveal the name so far because they are under NDAs. But if once we just build a case study with them and it's publicly available, we will definitely be happy to publish it online and share other names. But yeah, so far just we cannot unfortunately reveal it. So must have soil samples for ROTC. I think Regina, you can answer this question.
Yes, of course. So for this model, we need soil sample, but not that much as for baseline. We need soil sampling for calibration of model and for validation result we get. So, I mean, our scientists provide information that we can save up to 90% of soil sampling. So, yeah, so we need just 10% for calibration and validations, but it depends of the customer request. Sometimes customers would like to models 60% and to take 40% of soil samples to calibrate and validate it. So yeah, first, of course, we can do forecast without soil samplings, but we would like to take some of them to calibrate, validate, and provide really accurate results. Yeah, thank you.
Thank you very much, Regina. So I think there is another question which is for you, I think. So can we have the paper on those governmental initiatives?
Yes. So if I understand right, these government initiatives about soil organic carbon, we can provide some paper, but please contact us via email and we can send you the links. Of course, we don't know all countries' governmental initiatives because it's really, really hard to find all of them. But yeah, for countries we work, we can provide some paper where describes the local initiatives. But from my side, I would say that not every government support for now soil organic carbon initiatives because to be honest, it's really kind of new fields, kind of new, I don't know, interest models. Yeah, so not every government have it, but some governments have it, and yeah, we can share, no problem.
Yep. Thank you very much, Regina. We have a question from Sixbert from Rwanda. We wish we could implement such methodology. How can we do this? Is there any way of collaboration, especially on material, equipment, and consumables? Yeah, Sigbert, please feel free to reach out to us at sales@eosda.com, and we will just contact you, and we can explore further. But we need soil samples to get started if we're speaking about specifically on soil organic carbon modeling. So, but anyway, if it's the question relates to soil organic carbon modeling, please reach out to us, or if it's related to any other projects you would like to explore, also please feel free to send us an email, and someone will reach out to you eventually. So another question is, what's the COP position on methodologies for soil organic carbon sequestration and carbon credit generation? Is it a tool to help manage REDD plus projects and a standalone alternative or change to get premium? Okay, I think, Regina, I think you can answer this question.
I would answer like personally, because it's not like a product scientific question. I just researched a lot of information about carbon credits and of course about COP and all this thing was going on in our earth. So yeah, the carbon credits is a idea to stimulate people to create to sequestrate soil organic carbon in their fields, because farms, they also pollute CO2 and other greenhouse gases. Yeah, and so the idea is to use these fields to sequestrate this carbon. And yeah, for now, I mean, it depends of the country, but for now, as we know, it's initiative of the farmer. So the farmer would like, or carbon project developers who works with farmers, they would like to take a part of carbon credits. They decide to change a bit their activities on the fields for sequestration to earn some money on it. Yeah, so for now, it's from my side, I would say that it's initiative from farmers or carbon project developers. It's not mandatory. Yeah, and I don't think that I can answer for HDD plus projects because it's forest projects. Yeah, and I know more about soil organic carbon. Yeah, thank you.
Thank you very much, Regina. So let's move on to another question. Soil sampling is a must, but can we get the tests done from the local lab, or we have to send the samples to EOS Data Analytics? So I can answer this question. So first of all, you can definitely do this from the local lab, and you can send us test results afterwards. So you don't need to send us like physical soil samples, but you can send us like test results from the local lab, which we can use to set the baseline for you. So I hope I managed to answer the question. And this another question is, do you take into consideration soil classification mapping already available? So I'll try to answer this question as well. If I got it right, we definitely can include into one of the predictors as soil classification mapping, because we are using like more than 140 predictors up to 140 predictors. And we can definitely use one of them as the soil classification mapping, depending on the like specific solution and circumstances. So the science team who will be developing this, like training the model and doing modeling for you, will definitely decide which predictor is best to use for this project. Okay, so how affordable is your API for insertion in an independent app or web page development? I think it depends on the number of requests you're planning to send us to the servers. So if you're planning to build something and you're building an application or web interface and you're looking for an API datasets, please reach out to us, because we have, like, I would say, several packages that will definitely help you to kind of build something that you need. So of course, please reach out to us at sales@eosda.com, and we will help you with to answer this question, and also do the demo of the solution. And if you need, we can also enable the free trial for you, so you can test the API data sets. Okay, so I think we covered all the questions. I hope we didn't miss anything, but if we did, please send us an email in case we missed something. We will be very happy to get back to you and answer all your questions and discuss your projects. But I think that's pretty much it so far. So we really appreciate your time today. Thank you so much for staying with us. And for those who stayed for such a long time, we really appreciate it. So please stay tuned. And for those who requested the presentation, and we will reach out to you directly. And also the recording of the webinar session will become available very soon on our YouTube channel.